Welcome, this is lesson 7.2, solving system of equation using substitution. Our goal today is to be able to solve system of equations using substitution. So, first thing we're going to do is take a look at our steps for solving by substitution. First thing we would have to do is solve one equation for either x or y. That'll be your choice. It's always best to pick the variable that has 1 as a coefficient because that makes it very easy to solve for. Once you do that, it's called substitution because you substitute the x or y in the other equation with parentheses. And then you solve for that variable. And then you plug your answer into either equation to find the other variable. And then at the end, you write your answer as an ordered pair. Unless it's a special case, then it could be infinitely many solutions or no solution, which we talked about with our graphing as well. Okay? So, I know this sounds really complicated, but once you get into the process, it kind of follows the same method the whole way through. So let's take a look at our first example here. So, in our first problem, we have y equals 5 minus 2x and 3x minus 2y equals 11. To be able to do this, I'm going to actually use this first case because they've already solved for y. And I'm going to plug that into the second case or substitute it in. So this becomes 3x minus 2, and then in parentheses, I'm going to put what y actually equals, 5 minus 2x, and the parentheses equals 11. Now it just becomes a regular problem to solve. Distribute the negative 2. This becomes 3x minus 10 plus 4x equals 11. Put your like terms together. 3x and 4x would give me 7x minus 10 equals 11. Solve this equation. You would add 10 to the other side. So 7x equals 21. You would divide out the 7, so x equals 3. So that is half of your answer. To get the other half of your answer, you would have to take this 3 and plug it back into one of these equations. I'm going to do the top equation. So that would become y equals 5 minus 2 times 3. So y would equal 5 minus 6. So y would equal negative 1. So my final answer here is 3, negative 1 as an ordered pair. To check that, we can always plug it back in for x and y. And remember, it would have to hold true in both equations to be the solution. Now we're going to take a look at another example here. We're going to take a look at y equals 2x. And 2x plus y equals negative 12. Again, the nice element is that they've already solved for y in this case. So, why not use that to your advantage? Just take that y and plug it into the second case. When you do that, it becomes 2x plus, instead of y, I'm going to have 2x equals negative 12. Put those together. 4x equals negative 12. Divide by 4. X equals negative 3. Take that x and you plug it in right into this equation here. This becomes y equals 2 times negative 3. So y equals negative 6. So final answer is negative 3, negative 6. Again, you can check it by plugging it back in for both equations, but it should give you a true statement when it works. Now, here's our first example where they haven't solved for x or y for me. So, I'm going to have to pick an equation and solve for x or y. Now, there is no wrong pick. It's just a little more difficult if you would pick the second equation and try to solve for x or y there, because you'd have to get it by itself by dividing. The easiest thing to do is to pick this top equation, and getting x or y by itself would actually both be very easy. So, I'm going to get y by itself here just by subtracting x to the other side. So y would equal negative x plus 4. So what I've done is I've solved this equation for y by subtracting x to the other side. Then I would take this y and plug it into the second equation. So this becomes 4x plus 2 parentheses negative x plus 4 equals 1. Distribute. So 4x minus 2x plus 8 equals 1. 2x plus 8 equals 1. Subtract 8. 2x equals 7. So x equals 7 over 2, 3.5, or 3.5. I'm going to leave the improper fraction of just 7 over 2 for my x value. Plugging that in, I would plug it into any of the equations here, but it's the easiest one to plug into is the one that I've already solved for y. So y equals the opposite of x, that would be negative 7 halves plus 4. To be able to add two fractions together, you need a common denominator. So this would be negative 7 halves plus 8 halves, which would be y would equal 1 half. Or 0.5 if you had the decimal. So my final answer here is just 7 over 2 and 1 half. Okay. And I'm going to go through one more example, just kind of showing you what would happen here. Again, you are allowed to solve for any variable you want. In this case, the easiest one to solve for is y in the second equation, because all I would have to do is add 2x to the other side. So this would become y equals 2x plus 5. Take this y and plug it in. So this becomes 6x equals 3. Take out y and put in 2x plus 5 minus 9. Distribute to get rid of your parentheses. 6x equals 6x plus 15 minus 9. So 6x equals 6x plus 6, putting my like terms together. Get my x's to one side, I would subtract 6x. When you do that, the x's do cancel. So that would leave me with 0 equals 6. Because the variables cancel, that is a special case. Because 0 does not equal 6, that would be the special case that is a false solution. So that the final answer is no solution. So remember, when solving your system, pick one variable, solve for it, substitute it into the other equation, get your answer, and then find the other variable.